It's a bit of a chilly day today, which means that it's a really good day for demonstrating what we mean by thermal equilibrium. So in the mechanics course, you learnt a bit about equilibrium between forces. So for example, for these blocks on the table, the forces acting on them are in equilibrium. We've got the weight force acting down and we've got the normal force from the table acting up, and those two forces are balanced. So thermal equilibrium is a similar concept for temperatures. When objects are left in an environment for a long time, they come to thermal equilibrium with that environment. And any objects which are at thermal equilibrium should be at the same temperature. So we can check that now for this wooden block and this metal block. You can do this with your students in a classroom with just a thermometer, but just because it's a little bit easier for us, I'm going to use this infrared temperature sensor now to measure the temperature of the block and the wooden block and the temperature of the metal block. Okay, so this wooden block is at 18 degrees C. The metal block is also at 18 degrees C. However, if I touch the wooden block, it feels a lot warmer to touch than the metal block, which feels quite chilly. And so later we'll be looking at conduction methods. So this actually comes about because the metal block's much better at conducting heat away from my finger. But getting back to thermal equilibrium, these two objects are both at thermal equilibrium with the surroundings. So this room is at 18 degrees C, which is why both the blocks inside the room are at 18 degrees C. So we actually have a really fancy name to call this law. So we call this law the Zeroth Law of Thermodynamics. And what the Zeroth Law of Thermodynamics tells us is that if we have an object A and an object B, and these two objects are at thermal equilibrium, both independently with a third object, object C, then it tells us that objects A and B must be in thermal equilibrium with each other. So basically this is just the law of commutativity, and it explains why these blocks are at the same temperature. Anything which is at thermal equilibrium with another body is at the same temperature as that body, and because both these blocks are at thermal equilibrium with the surrounding environment, it tells us that they're at thermal equilibrium with each other and hence are at the same temperature, even though they don't feel like that when we touch them.